Did you know that there are currently about 7,150 languages spoken around the world, belonging to 142 different language families? However, many of these languages are endangered or have already disappeared. Over the years, scientists have been studying and deciphering ancient scripts to gain new insights into human history. This work is extremely time-consuming, and some texts remain undecipherable. Fortunately, in our era of information technology, new tools are constantly emerging to automate this process. In this video, you will see examples of how artificial intelligence helps restore ancient languages. Throughout the history of archaeology, scientists have discovered many manuscripts written in ancient languages. Deciphering these texts has long been a major challenge, leaving about 90% of all cuneiform texts untranslated. However, collaborative efforts between linguists and programmers have helped solve this problem. In 2023, a team of German researchers managed to teach a computer to recognize, decipher, and digitize texts written in ancient languages. The first tablets subjected to this scientific work were from Mesopotamia, written in the Akkadian language. These tablets, which are over 5,000 years old, represent just a fraction of the hundreds of thousands awaiting deciphering. Unlike previous methods, the new artificial intelligence, based on OCR technology, converts 3D scans into machine-readable text and translates cuneiform with high accuracy. According to experts, many of these tablets contain governmental decrees, historical events, and everyday records. The only texts still posing challenges for the computer are poems written by Mesopotamian poets. The creation of artificial intelligence has enabled researchers to learn more about the lives of Mesopotamian people and uncover new chapters in ancient history. Jiaming Luo, originally from China, had been fascinated with ancient languages since childhood and dreamed of developing a program to help scholars decipher cuneiform texts. After finishing school, he enrolled at the Massachusetts Institute of Technology to study programming. In 2015, Luo revisited his dream and began working on artificial intelligence capable of decoding ancient scripts. Luo and his colleagues from the university developed an algorithm based on patterns of language evolution over time. They then created a database of ancient and modern words, aiming to match words from lost languages with their modern counterparts. The algorithm was designed to work with most languages. The first tests of the AI were conducted on Ugaritic script and Linear B. Remarkably, the computer accurately translated texts in Linear B, which took American philologist and archaeologist Alice Kober over 6 years to decipher. In contrast, the program completed the translation within hours. The team also succeeded in translating Ugaritic script into Hebrew, as Ugaritic is an ancestor of Hebrew. However, this groundbreaking development was not welcomed by everyone. Despite its success in optimizing the deciphering process, some scholars criticized the program, arguing that many unknown languages have no connections to modern ones. In March 2023, an unusual competition called the Vesuvius Challenge was held, inviting participants to decipher the Herculaneum scrolls buried under volcanic ash after Mount Vesuvius erupted nearly 2,000 years ago. The scrolls, discovered in 1750 at a ruined villa, posed a unique challenge, as they were completely charred and almost impossible to unroll. However, advancements in digital technology have made it possible to tackle such tasks. In 2018, scientists from the University of Kentucky devised a way to read the text on these scrolls by scanning the artifacts with X-rays and using software to virtually unroll them. This produced images of the texts that required further deciphering. The Vesuvius Challenge was conducted online. Scientists shared images of the scrolls and a program capable of recognizing symbols from the X-ray scans. The best-performing team consisted of 3 20-year-old students from Germany, the US, and Egypt. They managed to restore about 2,000 symbols, or 15% of the entire text. For their work, they received a reward of $700,000. In 2020, Google introduced a new tool called Cyber Rosetta Stone, named after the Rosetta Stone, a key artifact discovered in 1799 near the town of Rosetta that helped scholars decipher ancient Egyptian scripts. the translator integrated into the Arts and Culture app, became the first tool to interpret hieroglyphs and translate them into emojis. Users can also translate modern text into ancient Egyptian. The app is powered by an innovative system called Fabricius, which uses machine learning to scan files and perform translations. According to the developers, their primary goal was to create a user-friendly tool that would help historians, archaeologists, and other researchers explore ancient Egyptian scripts. This idea was well received by many specialists, though some argue that it cannot replace a human expert in reading ancient inscriptions. Linear B is the later form of Cretan script, dating from the 15th to the 12th centuries BCE. Clay tablets inscribed with this ancient language were found in the largest cities of Mycenaean Greece. Its predecessor, known as Linear A, was displaced after the Achaeans conquered Crete. The first attempts to decipher Linear B tablets were made in the early 20th century by British historian and archaeologist Arthur Evans, who discovered the script but failed to decode it. In the 1940s, American historian and archaeologist Alice Kober began studying the Cretan clay tablets. She identified possible paradigms of noun declensions and created a card index of 186,000 entries, recording various spellings of Linear B signs and searching for words with identical roots but different endings. Sadly, Kober died of a serious illness before completing her work. Thanks to her efforts, however, British architect and self-taught linguist Michael Ventris, along with British linguist John Chadwick, managed to decipher most of the signs in the Minoan language. Yet some signs remained undeciphered. This problem was eventually addressed by programmers from the Massachusetts Institute of Technology, who developed an algorithm capable of translating Linear B texts into Greek. Testing revealed that the AI successfully translated 67% of cognate words. Linear A, the predecessor of Linear B, is a writing system used by the Minoans from 1800 to 1450 BCE. This script remains largely undeciphered due to the lack of bilingual inscriptions, unlike the Rosetta Stone. Linear A originated from Cretan hieroglyphs through the simplification of their shapes and forms. This script was primarily used for administrative purposes and consists of 300 distinct signs. These signs represent both syllables and unique words, some of which were used only once. Linear A also includes a numeric system, with vertical dashes representing units, horizontal dashes for tens, circles for hundreds, and circles with rays for thousands. For example, the number 9 was represented by 9 vertical dashes, while 900 was denoted by 9 circles. Nearly all Linear A clay tablets were discovered on the island of Crete, with the first found by British historian and archaeologist Arthur Evans in the early 20th century during excavations in Knossos. Today, Linear A remains only partially deciphered, with only 1,400 inscriptions discovered compared to 6,000 for Linear B. Without bilingual texts to serve as a key, researchers are now developing artificial intelligence to fill in the gaps in deciphering this ancient language.